need someone's hand to lead me through the night. I need for someone's arms to hold.
Okay, number 3 tells us to use the double angle, half angle, or power reduction formula, basically anything you can think of and will work, to rewrite this expression here without exponents. So the first thing I'm going to do is just break up the sine to the fourth into two sine squared terms. So we have cosine squared x times sine squared x times another sine squared x. Okay? So let's say we have something like this. We can keep in mind the power reduction formulas, which are cosine squared x is equal to cosine of 2x plus 1 divided by 2, and sine squared x is simply equal to something similar, but now we have 1 minus cosine of 2x and then divided by 2. Okay? So if we plug those in here for each of these terms, so we're going to plug in this thing, so we have cosine of 2x plus 1 divided by 2. Okay, so that's plugged in for the cosine squared, and then we're going to plug this guy in twice. So 1 minus cosine of 2x over 2, and then times another one of that same exact thing, 2x over 2 there. Okay, and then let's see what we get. So from multiplying these first two terms together, this one and this one, we can actually get 1 minus, and then we have cosine squared of 2x over, and that becomes a 4 on the bottom. Okay, and then on the right hand side we just have that same thing, 1 minus cosine of 2x and then divided by 2. Okay, so this thing here, that's another, we need to apply a power reduction formula there, right? So if we plug this exact same thing into here, but now instead of having x here, we're going to have a 2x there. So for this place, we're going to have a 4x. So that becomes the following. So we're going to get 1 minus. So this thing turns into the exact same formula, but now we have 2 times 2x. So that would be a 4x plus 1, and then over 2, and then divided by a 4. Okay? So that's what that turns into. That's the left term there, and we're going to multiply it again times that 1 minus cosine of 2x, and then divided by 2. Okay? So now, let's see what this simplifies to on the next slide. So we have 1 minus, and let me just rewrite everything so we're all on the same page. Cosine of 4x plus 1, and then over 2, and then this is being divided by 4, okay? And then we're multiplying it times 1 minus cosine of 2x, and then divided by 2, okay? So on the top, I'm just going to get that common denominator there. So this will turn into a 2 minus cosine of 4x minus a 1 over 2, and then over a 4, okay? So 2 minus 1 will just turn into a 1, but we'll do that on the next step, and I'm just going to rewrite this second part that's just kind of tagging along at this point. Okay, so then we have, on the top, we have 1 minus cosine of 4x, and we can combine the denominators into an 8, okay? So now we have something like this, and then we have 1 minus cosine of 2x over 2, okay? And then finally, we'll just get something like this. We're just going to FOIL out. We can combine the denominators into 1 over 16, so we can just get that out of the way. And then we have 1 minus a cosine of 4x, that's the inner, minus cosine of 2x, that's the outer, and then lastly a cosine of 2x times a cosine of 4x. Okay, and you can't forget that last parentheses there. Alrighty, so that is it. That's how we reduced our cosine squared x times sine to the fourth x into sines and cosines, well in this case just cosines. It ended up being to the power of 1. Okay, so here's number 4, the final question for our practice problems video. We're going to prove this identity here. So what I'm going to start with on the left side is just foiling this out. So we're going to get sine squared t, and then minus, well let me actually just write this out so we can see how we're going to FOIL exactly. So we have sine t minus cosine t being multiplied by that same thing, sine t minus cosine t. So here I'm just going to work with the left side first and see how far we can get. So this will turn into sine squared t minus a 2 times sine t cosine t, and then plus a cosine squared t. Okay, so let me just rewrite this. We'll rearrange the order. Sine squared t plus cosine squared t. I'll just group those together to kind of allude to something. And then we have plus, well, let's just say minus a 2 times sine t cosine t, Okay, so this guy here, we can reduce that using the Pythagorean identity. That reduces to simply a 1. And this thing here, we can reduce that, or not reduce, but kind of consolidate it, transform it into a 2, a sine of 2t. Okay, because that's a double angle formula there, or double angle identity. So this turns into 1 minus sine of 2t, and that was working from the left side, right? And this actually equals exactly what we see on the right-hand side. So we have just proved that identity. Okay, so that concludes our practice problems video on the section on double angle identities. I hope that helps, and good luck on your homework.